Welcome to the Patreon-only overhaul of the Sony TR72. This is an old AM radio, 7 transistors, goes back to about 1955. One of the first AM radios ever made that was solid state. Got a nice little wooden cabinet. These things are actually quite collectible and very valuable today. So we're going to do a complete restoration here on this Patreon-only release. Now, what makes this radio so unique? Well, one, it's in a wooden box. But two, check the logo on the front. It was the original Sony logo before Sony went to their modern day logo. This was the original Sony logo. This radio was actually produced before Sony was even available in Canada. And when Sony came to Canada, it was distributed by General Distributors, and it was I believe it was the Transistor 6, the one that I've got, was the first one that came out in about 1963. This predates that by several years. And it's quite a collector's item. We're going to start by giving this one a clean the control with some Neutral. Clean the volume control on here. We're not receiving anything, so I think we're going to have to start changing some parts in here, more than likely capacitors. For those that are watching, there's going to be 2 releases of this video. The free version is this. You're going to see the actual radio fixed, but I'm not going to do the full restoration. The full restoration is going to be a Patreon-only release. So if you want to see the entire restoration, you're going to need to be a member. Kind of like this, underneath the batteries, there's a screw hole ding chassis. It's a hole ding chassis screw. Let's remove that. That should allow the chassis to be removed off this thing, I think. Never worked on one of these before, but this goes back to like 1953, so this is a pretty special radio in terms of rarity. This sticker is coming off of here too. It's already out, so I'm just going to remove it so that it doesn't get damaged. As you can see, it needs to be re-glued, I think. Okay, what else is holding this chassis? Obviously the controls have to be disconnected because there'll be screws on here that hold these controls in place up top here. Just have to remove these so that I can remove the knobs and then get access to the actual chassis itself. Need a smaller screwdriver for that. I noted the last person to work on this did not bother to center the controls. They were all off. So when I get this thing back together, the controls are going to be properly centered. That one isn't tight. Remove that knob. We have to do the same for the tuning knob. See what I mean? Check the pointer. Where the dial is, it's way off. Also, look, someone's bodged on just a red wire there for an external antenna. Obviously, they broke the antenna jack, and rather than replace it, they just stuck a wire on there and used that as an external antenna. We'll be leaving that as is. Now I've got the 2 knobs off of the radio itself, and now I should be able to remove these other screws here on the top, and that should release the chassis from the wooden cabinet so that I can work on it. These old wooden Sony radios are actually quite valuable. Now this is very similar to my own Sony, except for this one's just a little bit older. This would be about 1956, and mine is in about 1963. So this was a little bit more of a collectible. Well, they're both very collectible. Both of those radios are very collectible radios because they're not too common Either one of them are not too common. I've seen listings for this show up on eBay. I haven't seen any listings for the one that I have. There we go. Okay, now the radio lifts out. Here's the speaker wires. There's a fair bit of slack on here. We'll just put the antenna back in place to keep it from being damaged. Okay, I've got the chassis of the radio out now. We can take a look at the actual circuit board. There's two circuit boards on this. There's the amplifier board over here, and then there's the tuner board over here. So I think what we'll do on this is we need to isolate where the problem is. Is the problem on the amplifier board, or is the problem on the tuner? Now with the long speaker wires here, we can actually remove the radio. You can close the back up so it's out of the way. And now we can work on this. So I'm going to reinstall the batteries. And I'm going to see whether we can get a signal from the amplifier. And that'll tell me whether the problem is on this board or whether the problem's on the radio board. So the first thing I need to do is generate a signal. And I can do that with this ugly function generator. So let me get a power supply for that. We'll power this up and inject some signals into the volume control and see whether I get any sound. I got my other one here, but this one should do the job for this. Okay, I got the function generator set up, 440 hertz tone. Let's see whether we get any sound through the amplifier. So I'm just going to find probably a ground right there. Okay, we'll turn this thing on, and I'm going to clip onto the audio input, and haha, sounds good to me. Control's still really dirty, but that tells us that everything on this board here is fine. So the problem is on the RF side. Now, where is it coming over to this other board? Right there. Right? That's because that's the brown wire. Where does this go? I'm just tracing some wires here. That one actually comes up over here. It's a yellow wire, so this is the one. Yeah, that's the audio out. So let's see if we first of all have any voltage getting to this board on this side. So get the meter out. We're going to probably use a scope on this one. Okay, red probably is going to be B+, I would think. I see 1 volt. What, minus point? So we have no power. I think that's going to be our problem, is that we have no power getting over to this board. What does this red wire go to? Red wire comes over to here on this board. Okay, so this is the audio output. This is the audio driver transformer. Red wire here goes over to the switch, no doubt. We have 4.2, so our ground is actually not the chassis. So let me just ground the meter to the actual. Great. So much for these new leads I just bought. I just went to grab one and it fell apart. So much for those. I guess I'll have to solder them on. It looks like these test leads I just bought. It looks like they just crimped them. I wonder they don't work. Okay, we'll try another one here. We'll try again. Ground. I just bought these test probes, or these test leads, jumpers, and I've hardly used them. 4.82 volts. Okay, that's our power. Let's just see whether we're getting any power over to the actual tuner board. I would imagine that this one should be, the voltage is 3.8 volts, so I think we're probably okay. We have got power. Getting to the actual tuner board itself. If we inject signal, we'll hear it coming back. Well, we were. What happened to my signal? There we go. So I'm going to get in here with the scope and just look to see if the oscillator and so forth is running. Look folks, these transistors say Sony on them. It's a Sony transistor. First we'll see if the oscillator is running. So I believe the oscillator is right down here. So we'll just clip on here and see whether there's anything coming from this transistor. Well, I'll show you guys the scope in a second here as soon as I hit the auto button. Get it to measure our oscillator, our local oscillator. And if I adjust the tuning capacitor here, this should change the frequency. Just going to tighten down the screw here just so that it makes a contact so I can actually turn it. That didn't work. And now, as you can see, the frequency is changing. From 917 kilohertz all the way up to 2.17 megahertz. So it's 922 kilohertz approximately. 915. It's just it tunes down a little bit lower than the broadcast band. Take off your 455 kilohertz IF frequency, and that would give you about 460 when you mix the two of them together. If we turn the dial up, you'll see that it goes up to 2.17 or 2170. Take away 455 and that gives you 1715. So that's your AM broadcast band. So we know that the oscillator is working. So our problem is not the oscillator that's causing this radio not to work. I know I've got this crap sitting here advertising. Give Lofttech some free advertising from one of the devices they sent me to test. So that is not the problem. It is not a problem with the oscillator. We know that that works. So I have to concentrate somewhere here in the mixer, and I'm thinking probably some of these stupid capacitors are bad. Looks like this one's been changed at one time. This 100 microfarad at 6 volts. This one's been changed. You can see someone just cut. Somebody just cut the leads and they were lazy. Rather than take the board out and do it right, they just cut the leads. But I'm going to do it right. We're going to change a couple of these caps. These 30 microfarad at 6 volts. I think these ones are probably going to be okay, but these electrolytics here, I don't trust these things as far as I can throw them. And these little ones, I can probably throw them a pretty good distance, but I still don't trust them. I think that we're going to have a problem with them. And I mean, I can confirm this. We can bridge some new ones in here. This one looks like it's starting to come apart. It looks like the rubber plug down here is actually leaking. It's ready to pop. But let's get some new ones. These are 30 microfarad. I'm sure I've got some 30s. They're going to be a fraction of the size of these things. They only need to be 6 volts. Well, I don't have anything that small, but we'll find something that we can put in here, and we'll get these caps replaced. We'll do all these ones, because I think that if one's gone, the rest of these will also be gone. And I'm doing this is a restore for a long-time customer I've had for a while that I've done a lot of work for him. It's owned by the same fellow that owns well, a lot of those high-end amplifiers that we saw, like the Leak and the or some of the other ones we had, the Haflers, and that Marconi radio is same collector. So we're going to change all the caps on this. Let me go find some. So I've got some 33 microfarad at 25 volts. I think that these are going to be more than adequate. Look at the size difference in these things, right? Compared to these big ugly 6-volt axial lead. You know, I don't have any axial lead. I've got PC mount, so they're going to go in here and not take up much space. But look at the size difference of these things. They're just ridiculous how big these old ones were compared to the new ones. So I'm going to remove these and put new ones in, and we'll just do these two first and see if that will get the sound back by doing these two on this board. And then I'll deal with, we know the audio amplifier works, so I'll deal with that after we get the radio putting out some sound. So let's take out the first one here, and we'll note the polarity is this one here, the polarity is to the right on this side, and the bottom one here, the polarity is on the left side. So let's remove this one first. Get all this stuff out of the way. So that one should be this, one of these wires here. That's that one. That's this positive lead I just took out there. So we'll get this one in place first. It's this one here. Okay, that one's done, or the positive lead is, and that one went to, they both go to the same point on the other side of the board here, so they're both connected to the same common place, so it doesn't matter. But that's this one here. So that's one, and then the other one is next to it, and that would make that one here, I think. I can see why the last guy just cut it, because they bent these leads over, and I don't want to damage the traces trying to get this thing out of here. There's this one here, I think. You know what? I'm scared that the trace is going to get damaged, so I'm going to do what the last guy did. I'm just going to cut the lead here. I know somebody's going to give me a thumbs down for this for sure. I'm just going to cut the lead and do it this way, because I don't want to damage the board. And these old circuit boards that are this age, this is early in the manufacturing of printed circuit boards, and they really didn't have PC design down pat at that point. So they basically go over all the traces with solder to make things stick, and it makes it hard to get the components out. Plus they bent the leads over, because these were all hand soldered back in the day, right? So they bent all the leads over, and then they soldered them down to the board, and you basically have to heat them up and bend the pins up in order to release them. And doing that, you put a lot of stress on the board, and I just don't want to risk having any traces lift on me. And that's probably why the last fellow that replaced this cap just did exactly what I'm doing here. Just cut the old one out, and just going to tack the new one in like this. This side was okay because there was nothing on this side other than the only parts that go on here is this cap that goes to ground. So this one was easy to get at, but the other one not so much. So we'll do it this way. There we go. And through the board, we'll pull these two caps down as much as we can. Get them out of the way so that they won't touch anything. And solder them down to ground. Okay, those two have been replaced. As you can see, they are, looks like they were made by Union Carbide. Look at the logo on here. But you can see that the rubber cap here is, the camera will focus. Come on, camera, you can do it. I think this thing's got to be on a wide shot in order to focus up close, but there we go. You can see the positive terminal there is not in very good shape. Okay, those two replaced. Nothing touching here. Let's put the batteries back in and see if we have liftoff. Nothing yet. Okay, next one, we'll do this other one here. I'm hoping it's not a bad transistor, one of these transistors here, because, well, we know these ones are okay because we've got audio output, right? These four are fine, but I'm hoping, we know that one's okay because it's oscillating. So we got a mixer here, IF stages. I'm hoping one of these is not bad because these being the age that they are, it's going to be pretty hard to try and find a capacitor, or sorry, pretty hard to try and find a transistor that would be work to replace this, because these will be for sure germanium transistors, absolutely positively guaranteed germanium transistors, because silicon transistors had not been invented at that time. You see how someone changed this before? This is 100 microfarad. We'll just do the same. Even measure this thing. Maybe this thing's shorted, or maybe this thing, well, we can test the ESR. But we'll just we'll take a look at this this capacitor and just see whether it measures anything. We'll check it with the capacitor tester first, our capacitance tester. See if there's any microfarads left in this thing. It's measuring 174, so it's probably okay, this one. ESR this one, and see what the ESR does on it. .95, 100 microfarad at 6 volts. A new one would measure 1.2. This cap is not the problem. I can guarantee that this one's not the fault. So I'm going to put this one back in the radio. Because we know that that one is not causing the fault. One thing I've noticed on the bottom of this unit is somebody has changed a resistor here, and if we look at this lead here, oh yeah, that's well soldered down. I'm saying, looking at the solder there, it's kind of questionable, but it broke. So let's just tack that one back down. Maybe that's the fault. Okay, that's a little more secure. We'll load up the batteries again and see whether anything happens. I'm just curious what's going on with this wire that someone took out for the antenna as well. It's like they had an external antenna. Did they disconnect the internal when they did that? That's a good question. I spy a wire that seems to be going nowhere. Right here. What is that? Where did that come from? It's right in this mess down here, and next to this transistor I see this wire. And it looks like it's a resistor that's come off from something. I guess I need to remove this circuit board and take a closer look at where that goes to, because that is obviously not supposed to be floating in free space. You see what I mean about these circuit boards, eh? This is early PC board technology, and it wasn't that good. Okay, let's just see where the heck this. Oh, the transistor's unsoldered. Ah, I think this is our problem. Look at this. This transistor is not even soldered down, and where the heck is this resistor go? Okay, there's a resistor here that is just like, where did it come from? It's come right off the board. See if I can get that out of there without breaking anything. There's a resistor that's fallen off. I wonder where that went. And the transistor has come unsoldered. That should be relatively easy to put that back in because there's a hole there. I can see it. I don't know where that resistor goes, but I do see a couple holes over here, and I'm wondering if it came... You know what? I think it came off right here. I can feel... This is the one that's been replaced on the bottom. I can feel the... It's broken. This is where this has come from, right there. I can feel the pins sticking up. Interesting. Okay. What else am I going to find on this thing? Let's tack this transistor back down here. I think it's just the one lead that's come out. It's going down to the board right in here somewhere. See if I can straighten that lead a bit. Man. Probably that one there that lead broke off of. I bet you that's where it goes. Is that it? Yes, indeed. If I shine the flashlight from the bottom, you'll see that lead here, this one right here, is where the light's going to come through. Right, that's from that transistor. That's the one. This is my little work light that I got sent to evaluate, and I tell you, this thing is actually pretty good. Even for working on stuff like this, I can put this on my bench and throw a little bit of extra light on the scene when I need it. Like today. Can get in here a little easier. Okay, we'll get that out of the way. Now I've got two leads broken on this transistor. I might as well remove it completely and reinstall the stupid thing because the leads are breaking right at the board. I think this is the third one here, if I'm not mistaken. It's this one right there. Okay, that should allow this transistor to come out. Nope, it's not that one, it's this one over here. It's this one here. See what I mean? How they bent them over and then they soldered them down, and it makes it hard to do any work on these things. There's my transistor that's out there. Very obsolete. I really am nervous working with these because I don't want to break the leads, because the chances of ever finding one of these transistors again ever is pretty slim. There's obsolete and then there's obsolete, and these are right up there for being on that obsolete list. Let's figure out where the other one went. It was right next to it. It went like right here. One lead there, and one lead up here. That there's nothing. I don't think that's a hole in the board. So one was there, and I think the other one was that lead right there. And this other thing, I don't even know what that is. Oh, that's a capacitor that I had unsoldered there. I'll just put that back down. The other lead is going to be right there, I think. That should come out because it's broken right at the level of the board. So when I heat this up, this should come out, which it does. Okay, so there's the transistor that's going to go there. 1 pin, 2 pins, and 3 pins. I have no idea even what the basing on this thing here is, and I don't even want to put it on my meter because I don't know what the current limitations of this are, and my fluke meter might have too much current and it could pop this. So I don't even want to try and test this thing. I just want to get it back onto the board and solder it down. I'm sure it's probably okay. But let's just see whether we can get this thing mounted back in here properly. That one there. I think I got it in. Nope, not quite. Shoot. Okay, I think it's there. I think it's going through the board there. 1, 2, and where's the third one? Third one should come through. There it is. I can see it. Stack that down while I can. Okay, that is reattached. We'll replace this 0.5 microfarad. I'm not going to replace it, I'm just going to solder it back down to the board. I'm sure that this is probably okay, because I think we know where the problem with this radio is now. Okay. Now this resistor that I know where it came from, and I've just had a wire break off here. That's what I hate about these type of boards with all these wires sticking out of them. This resistor, I'm going to mount it on the bottom right next to its brother that fell off before, just to make it easier to tack this thing down. That's what's happened with this other one. This other one broke off before and someone just stuck it on the bottom of the board. This one goes right next to it here. So I'm just going to do the same for this one. I'm just going to stick this one right next to it on the bottom of the board. And the yellow wire that's come off over here, the audio out wire. Okay, we'll just reattach the board now to try to prevent anything else from breaking on this thing before we get it tested. So there's the board in place. We've got a couple of screws here to put in, and these screws are going to be these stupid non-magnetic crap screws that Sony was good at using, so we'll just kind of put them in place here and put them in by hand if we can. The repair guys got to figure this out. What we used to do was we used to light a candle and dip the end of our screwdriver in the candle into the wax, and then we could pick up the slotted screws with it. Fortunately, I don't have a candle here to do that, but that was a trick we used to do in the field when we had to do these type of screws. Is we'd just get a candle and light it, and then dip the end of the screwdriver in it, and let the wax harden on the end of the screwdriver, and then that would allow us to pick up a slotted screw. These non-magnetic screws used to work like magic. I hear nothing. We're going to look for some signals with the scope. Okay, I see something here. Okay, I'm seeing a signal here. It represents audio. That looks like audio to me. Actually, that looks like an IF signal. That looks like a carrier with audio. So, it was making it through this first IF stage. Let's go to the second one here. This is the transistor that I just put back in. And that's one side of it there, and that's going into, it looks like it's going into an IF transformer. Here's what's coming out of that IF transformer. What do we got here? So we have a signal here. I think it was here, or was it? Or was it here? It was here. And that goes into, looks like it goes in here. Goes to this point here. And then from there, it looks like it goes into a capacitor. Maybe not. I'm looking to see where it goes on this board here. It's right in this area here. Does it go to that capacitor? Yes, it does. Does it come through that capacitor? Oh, what do we got here? It doesn't. We may have a broken capacitor here. To whatever this goes to. I got nothing on. Oh, I got signal there. That's the capacitor, I think. And then from there it goes into this transformer. This is the IF transformer here. So the other side of that IF transformer should be here. And I see something, but I don't see an audio signal. And then that goes into this. And what the heck is that? That might be this capacitor here. There's another transistor stage right down here. And I see that. No, I see this. Is that? Okay, I see RF here, or IF. Especially considering I see audio back a stage back, we can certainly see that that's an AM modulated waveform there. That's definitely speech from an AM station. If I put my hand near the antenna, it increases, and that is going into this transformer, the IF transformer here. It should be coming out of the transformer there, which it looks like it is. And that goes into, I believe it's this transistor here. Let's see if I can find a schematic for this thing. I haven't even looked. See if I can find a Sony TR72 schematic. It might make things easier to track down. So we've got the schematic for this unit. And let's study it. So here's our oscillator. We know that your signals go good here. This is the transistor here, 2T51. They're the same. 2T51, 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 and then it's got two 2T61s and a 2T62. So and a 2C61. So 2T61s, I guess they are PN. One's a PNP and the other's an NPN. It looks like no, they're all NPNs. Interesting. 2T61, yeah, they're NPN. 2T62 is an NPN. 2C61. 2T50, they're all NPN transistors on here. Okay. Anyway. Alright, we've got our signal going into this transformer here. This is we've got it going in, and I see it on the base here, but I don't see anything on the collector from this transistor. And this resistor here might be the one that came unsoldered. I'm just going to look on the bottom of that board where I tacked it down again. Let's take a look at that resistor. that might feed into this. Let's just see if there's voltages here. This is where we get the fun part, right? When you start to chase down electrons on obsolete equipment. Okay, I can hear it hissing. 3 volts, minus 0.6. Minus 0.6 volts. That is the brown wire here, wherever the heck that goes. Brown wire comes over to this board over here. Okay, that's 0.6. 3 volts on that capacitor. Nothing on this one. The transistor, 3 volts here. This one's the where am I here? This is the collector of this one here, TR2. I think that's the collector. It goes into the transformer here. So this other transistor here should pick up its power. Power should actually come from the third transformer over, or no, that's the secondary winding, I think. That'd be the secondary winding. This would be the third one. This is the third transformer over. The power should come in from that, looks like. And that should be fed from the 6 volts, should be coming in here. We know it's got power because it's feeding these other transformers as well. So there should be 6 volts coming in here, and should end up on the collector of this transistor here. So on this transformer, we should have power. We should have power feeding in. 3 volts, 3 volts. Okay, we do have power feeding in here. And it ends up going to a transistor, and it ends up going to the collector of TR3 collector. I think that's it here. Okay, that's the base. And this should be the collector here. There should be audio signal on this one, if I look. On the scope, which there is. Okay, there's a strong signal there. And that should be making it through. We can hear it. And here it is here. Going over to the detector. And there's the detected output. Really low. It could be one of these filter. It could be one of these coupling capacitors here that's bad. And this is our rectifier here, right? Our detector, IT33. This diode here is our detector. Our volume control is right here, so this is the wire that leads off the board and goes over to the volume control here as our detector. This is where I have that strong signal, is right in here, right on this side of the transformer. You may have one of these little caps here might be going bad in here, or it could be this resistor too. That's going to ground. That's a 150 ohm resistor off the collector. Okay, if we look on this, this is the last IF stage. I think we can safely say that this is audio. And this is going into the final transformer here before detection. So we know we've got signal coming into that transformer here. And that would be the side, I'm going to say this is going to this collector of the transistor here. I think. I was trying to trace the circuit by eye here. Three pins on here. This one should be the collector here. Yeah, there's the collector. So the other side of this transformer is over here. And I see RF there. From here it goes to the detector. The detector has got to be right in here somewhere. Where the heck is the detector? Is that it? Oops. I thought a wire broke there. That's the detector? It's not a conventional glass diode like you normally would expect it. Oh, okay, what do we got here? I think that's the detector right there. That is the detector. This is the detector. This brown component here is the detector.
Now, here's the latest from the TR72 newsroom.
A second former Metro Vancouver mayor has entered the race to become the next BC Liberals leader.
Former Surrey Mayor Diane Watts is
No.
former Vancouver Mayor Sam.
It's the detector. Son of a gun. This is the detector here. It's bad. I just put heat on it. Now it's gone out again. I just put heat on this thing and this thing started working. That's the problem. The bloody detector is shot. That's right here. Okay, that's right here. Put some heat on there again. See if it'll kick in. I should be able to replace this with just a standard glass diode if I have one. I should be able to do that. I just got to find a diode from an old AM radio that I can steal. But that should work. I'm sure that that's the fault. If we put the scope on there again, I should be able to clip it on here. We'll see the RF here. Okay, here's the RF, and our audio should be coming out the other side here, but it's not. Okay, let me see if I can find something that I can replace that with. Okay, I was able to find an actual rectifier or detector diode out of an old radio. Let's put the right type of detector in here and see whether this will affect my reception. And like before, I'm just going to tack it down to the bottom of the board here because it's a heck of a lot easier than trying to get it through those holes in this board that is not a very easy one to work with. I'm going to leave the little insulators on here. Okay, there's the diode in place. Let's see how this sounds, if it works at all.
Emails and watch the game at the same time with the multi-window feature. En français. Press your client by using the S Pen to display the translation.
You'll love the remarkable Galaxy Note 8 on National App. For details, visit a Bell store or bell.ca/network. Smartphones on Bell just got better.
Next time you take your vehicle into the shop, here's what I want you to do. Instead of the antifreeze you usually get, we're on the downtown corner
Sounding pretty good right now.
Garangle and Canby Street bridges. Very.
Now it's Justin Thomas, the winner. I mentioned the first two end.
Here and.
Here, guys, coming up here in moments right here on Fox Sports. We come back from the Fox Sports Radio Studios. Only we're looking for a reason to complain even more.
PC lines, oh baby! This is Bob the Moonsburn Challenge. Join me along with Julio.
We've got it receiving now, so I just want to mount this board before any wires break off of it. I think that at this point, this is probably working pretty good. It could use the all the rest of the caps changing on here, but I don't have anything in that size for these small caps. These are what are they? 0.05 microfarads. I have nothing that small. I want to get the radio working properly first, and then we'll look at swapping them out. Okay, now that the board is mounted again, let's put the batteries back in and watch it not work.
Station.
Oh, now the volume control is working now that it's grounded. That was why.
This is AM 730, Vancouver's traffic and info.
Oh, well then, that must mean that when you were asking for a raise, you were really asking for a pay cut.
Touche, Mr. Employee of the Month. Touche.
It's Sunday, September 24th. I'm Renee Bernard. In Vancouver, it's 15 degrees. Here's what's making news right now. It's official. She will be running to become the next leader of the BC Liberal Party. 3 separate shootings in 2 areas of Surrey over the weekend. So far, no suspects, but lots of rabbled neighbors.
Municipal leaders gather in Vancouver this week for their first convention since the NDP took power. Housing is expected to be a key issue. Russell Wilson.
So we open the back up again. And this will just slide right on in. Well, a bit of coaxing maybe. Got to wind up the speaker wire like it was before. Get it out of the way. And this should just with a little bit of coaxing. Like that. Just like that. And then there's these screws that go in the top, and then we have the knobs that need to go on, complete with the rotten felts. And this was set to 16. There. Now it says off when it's actually off.
At crossing, you're waiting about 10 minutes. Everything else northbound, it's just a 5-minute wait. Do keep in mind.
So, of course, now for my Patreon viewers only, I'm going to change out the capacitors on the audio board and change out the ones over here that I have. Again, this is for my Patreon viewers only. Regular viewers don't get to see this one. just because I want to try and make this radio as good as it can get. So we're just going to do a cut them out and replace them. It's the easiest way to do this, because we've seen how fragile these circuit boards are on this thing. So we'll take these ones out. Both of these go in the same direction. The positives are both on the side to the right here. So we'll clip these ones out. As you can see, the rubber is pretty much shot. So these ones are bad. I can just see now the guys on the free channel are gonna be, and then change all the caps. Of course I did. Just two versions, right? One to show the basic user what caused the problem, and then for the Patreon viewers, we get to see how well we can make this radio perform. See if I can get this thing performing even better. It's working now, but I think I can make it work better if I change out all of these caps that are going bad on it. Ain't pretty, but it'll work. Now I'm going to be really careful around these leads to these transistors because they are ready to shear off. That's what's happened on the other side. The actual oscillator transistor is also, by the way, somebody's in the past has reconnected this when they soldered the legs on it. What the heck are these? Silver. Are these capacitors? 6 volt, 3 microfarad. So there's a couple more. These ones here look like they're falling apart too. Look at the plug on these. These are 3 microfarad. Let's see if I can find something that's going to be suitable to replace those two. Six volt, 3 microfarad. What the other one? The other one I think is probably the same. Yeah, 3 microfarad, 6 volt. Let me see if I can find a couple of those things. So these are 3 microfarad caps. These ones with the red. That's actually the rubber top is coming off these things. So these are being replaced. I'm going to replace them with 3.3 microfarad. I don't know if I can get these ones out from the board itself because they're pretty close. I might be able to take these ones out. Got to remove the board to do this. This is why I don't like taking these parts out of this board, because the way that they've been installed, they bend the pins over, and you got to get the board hot enough to lift the pin up so that you can bend it back straight in order to pull it through the board. And with doing so, you really run the risk that you're going to damage the board. But I don't have any choice on this particular type of part because it is flush with the board. And these circuit boards, as you can see, the trace is starting to lift here. These boards are not, they're not very good to begin with. Just the early days of PC boards were not the greatest. So I'm trying to avoid damaging this thing as much as I can, and that's why I don't really want to have to remove components from the board, just because of the how fragile these traces are. Okay, that's one done. Got one more that we'll put in here. And there's this other one over here. Okay, that's the 4 electrolytics replaced there on the audio board. I think that's all the electrolytic. Oh, there's this big one here. I wonder if I should change it. It's 100 microfarads. Yeah, maybe we'll change that. It says peak 9 volts, so I think I can find a 100 microfarad cap. We'll just clip that one out and solder down to the pins, as I don't want to risk damaging the board. I'm already putting this board under enough stress as it is, and I still got to change a couple of these ones over here on this one. I think I'd like to change these green ones if I can. .1 microfarad. I don't know if I've got any .1s, but I would like to change them if I can, just so that I can. I think these other ones here should be okay. These orange ones, these are solid. They're not electrolytics, but I think these are electrolytics. They've got a positive mark on them, so I think they're probably electrolytics of some type. Same with this one here. But we'll change it. Oh, there's this other one here. Another 30. Where's that? Where's my other 30? Here it is. We can clip this one out. See, this has got to go, because if you look at the rubber on here, it's all dried out. these, I bet if I put the meter on these, they won't even measure close to what they're supposed to be. We'll just see if they measure anything at all. This is just for shits and giggles, right? I don't believe it. They actually still are. They're supposed to be 30 microfarads, and well, they're coming down here. Do I dare test ESR? They can't be any good for ESR. Through the roof, I say. Watch it make a liar out of me. Oh well, they're getting changed anyway. But 3 ohms. ESR. It actually tests good. Can you believe it? What about this big buddy one down here? This one, positive lead here. 0.3, 100 microfarad. Yeah, 1.2 is good. So this one's actually testing good. What about these these 0.1s, I won't be able to measure them anyway. They're too small, but they shouldn't show anything on ESR. I wouldn't think, because they're below the limit of the meter. But for the hell of it, shits and giggles, as they say. Let's just put the meter on here and see. Yeah, they're measuring open. But then I would expect that, because they're 0.1 microfarad and the meter doesn't really go down below about 1. What about if on the regular capacitor tester? What do they measure on here? Not measuring very good. It's not measuring anything. You can hear it in the speaker though. Okay, let's put this new one in here. This one came out this direction. Positive on this side. There. That'll keep it out of the way so nothing touches. Bend our resistors back where they belong. Okay, we could actually put power to this thing and just see how it sounds right now. See if it gets my volume up louder. I bet it does.
Fenway westbound at 3rd, dealing with
a little more volume.
delays to the Massey Tunnel.
My antenna line shorted out there. Okay, let's just mount this board back in place because I'm done on this. I'm not going to change this 0.1. I think this is okay. This one over here, it's a solid. I don't think it's electrolytic. Pretty sure it's a solid cap. Looking at it. Same with these ones here. I think these ones are probably okay as well. So now I've changed all the electrolytics except for this big one. And this one was changed before. It's testing okay. I don't know, maybe we should change it just for the hell of it. Why not? Let's just change it. Well, then I can say I changed all the electrolytics. This was a 100 at whatever it was, 9 volts. Let's find a 100 at 9 volts and we'll find a another 100. So let me get 2 100s and we'll change. We'll just do both of these ones here just for the hell of it. Then I can say I've done all the electrolytics on this thing, and well, you heard how much louder it made it by doing it. And it was probably these little buggers here that were getting to be in pretty rough shape. But these were also going bad, I'm sure. Let me find a couple 100s and we'll change the last 2 electrolytics, and then we'll try it at that, and maybe I'll leave it at that. I think these ones are okay. These are solid capacitors, and I think these are probably solid too. Looks like they have 250 working volts, so these have to be solid capacitors. These are not electrolytics, so they shouldn't. These green ones shouldn't go bad. They should be fine. They're just coupling capacitors for the IF. So we'll do all the electrolytics. And to give you guys an indication of how much reduction of size has happened in components, the original electrolytic here is a 100 microfarad 9 volt peak. I'm going to replace it with a 16 volt. Same with the other one over here. This is a 6 volt. We'll put a 16 volt in, but look at the size difference, right? So for this one, I'm just going to nip this out because I get nervous working on these circuit boards, which are really old like this. So the less stress I can put on this thing, the better. Extra pair of eyes always helps. Where to go? Yeah, it looks like we're gonna have to contend with the lawnmower. Neighbors decided to cut his lawn. It seems like every day he does this. Like, literally, every time I go to make a video in the afternoon, somebody cuts their lawn. At least I don't have to deal with the hockey puck kids anymore. Last week, I guess it was maybe 2 weeks ago now, I was going to go out and test my AM stereo radio and see whether I could pick up any stations, you know, out in the field. So I took an antenna with me and I was going to put it on the car and or hold it out the window basically and drive up to a hill where I could park and listen for DX and see if I could pull any AM stereo stations, and I had that AM stereo car radio with me. And I get in my car and I'm driving up the street. It's nighttime because I waited to do it at night. I wanted to see some DX come in. I saw something sitting on my window and I stop and I look and it's a hockey puck. Well, upon closer inspection, I discovered there's a nice dent in the roof of my car and my XM antenna is bent and it's no longer functional. So I go back and I look at my security footage. The neighbor with a kid with his friend was blasting hockey pucks and shot one over the goal that they had put up against the fence and right into my yard and hit my car. So I had a little chat with the father. He's like, his attitude was, "I don't believe you." And I said, "Well," I said, "I've got video. I want to see it." So I gave him a copy of the tape, and well, the hockey net has now been moved. But I still don't have an XM radio that works in my car because the antenna is broken. Not that I subscribe to XM anyway, but if I wanted to, I can't because now it's FUBAR. Okay, that's that one done. We'll do the other one on the other board and see how this thing sounds and then put it together. And of course I'll promote the Patreon channel on the regular channel to see the full repair, and that'll piss people off some more and I'll get a bunch of thumbs down and a bunch of people that threaten to leave, but you know, I know that they don't. They say I'm gonna unsubscribe, but they're blowing off steam. But you know, I think it's only fair that my supporters, you people out there that are watching this one, you get something extra. So we'll call the free video a fix, and we'll call this one total restoration. How's that? You get that? Sounds good? Okay, we'll just take this one out. There we go. I think that'll be okay. That'll be fine there. Make sure that my antenna wire is still connected and not shorting out to anything. Okay, let's put the battery in and see what this thing does. Well, that's not good. What the hell is it doing that for? Nothing is touching. Unless a wire came off of this thing. Did the wire break? I think one did. I don't know if there was one soldered down to that or not. I'll have to look. I'll have to look at the tape. I might have a wire that's come off here. Something's making it oscillate, that's for sure. I better pull this board and make sure there's nothing pinched underneath here. Ah, that's what's happened. See, I thought maybe a wire came off. A brown wire has come off there. That is what's going on. So we'll just reseat the board, reattach the brown wire, and that hopefully will get rid of that horrible noise. Okay, why we got no sound? We got no radio. What is going on?
It's getting higher. Quickly, those here in America, we have to talk to each other and find out who we want to be and how we want our nation to come across to the world.
A buddy transistor that came undone before, and I soldered it in. Obviously, it needs to be resoldered. Let's see if I can get at it from the bottom here and just try and heat it up a bit. Where is it? Here it is. There. Hopefully that's got it.
Focused, it was not hysterical, and it was to the point. What do you think Dr. King would say
It's not loud.
if he was
It's not
alive?
loud.
Record breaking in the morning. Bring it on. Good. That's tail.
Oh, and
Respective opinions. It's everything you need to be up to speed.
Thumbs up.
Join us now over at News Talk 980 CKN Leader.
This is AM 730, Vancouver's traffic and information station. With the most up-to-date traffic in Metro Vancouver.
Good afternoon. It's 4:42 and 16 degrees in downtown Vancouver. I'm Robin Crawford here in the traffic center. Coming up next, we'll check out the latest bridge and tunnel report. The weather forecast is on the way too, but first, here's Mark Staling with the traffic hotspot.
Yeah, it's not too bad out there this Monday rush hour, Robin. A couple of problems in New West. Looks like one of them might have been cleared. Yeah, it has been. It was on Stewardson westbound at 3rd. It's all gone. All I can see now is just a little eastbound delay at those lights at 3rd, which is
reallocated. Yeah. Therefore, it's music to our ear, the fact that the federal government and the provincial government seem to be
right up to 200th and open east of 208th where they're working there on the overpass, and again a small pocket right around the
that transit would no longer be objectives, and one of them is we want to contribute to make happen.
There we go. It's even picking up my signal. Everything's working great on this thing now. I'm just gonna put it back in its cabinet and send it on the way. Now it's completely restored. So once again, we'll fight with this thing to get it into the cabinet. It's not the easiest thing. I'm just gonna turn this capacitor also over so that it's pointing down at the board. There we go. Okay, now I got to get this thing into the cabinet. This is not the easiest thing to get in. It's very, very tight fit. And you have to have the back at just the right angle to kind of shoehorn this thing in. Like that. And then it goes in like that, and try not to break any wires while we're doing it. Oops, that's not the screw for that. That's the one that holds the battery compartment in place. Did that the last time I put this together too. Okay, that washer goes in there, and this final screw goes down into here. There. Now, all that remains to do is get the controls mounted again and complete with the .3. And that should go to 16, which it does. Okay, that one's done. Now the volume knob, same thing. I have to turn this thing almost to maximum to set it. That's what we want. We want it pointing off when it's in fact off. Then we just tighten down the 2 set screws to lock it in place. Reload the batteries.
Blade will bring very latest from Salt Spring.
And listen back 2, 3, 4 times a day.
News 11:30. Vancouver's breaking traffic and.
This is 咁所以到今時今日咧，係完全係冇人。6 months, and much of that time will now be. Is he getting off? Slowing down from that perspective. You came.
That's my transmitter. And it cranks. Well, it distorts when it cranks, but. There you go, all done. 1953 Sony TR72, full restoration, all electrolytic capacitors replaced. We had a transistor that broke off the board, a resistor that broke off the board, and what else did we have on this? I guess that was it. Yeah, the transistor, one of the mixer broke off the board. I think it was the mixer. Or one of the IFs. No, it was one of the IF transistors here. Well, I guess it is the mixer because that's your oscillator. Yeah, this would be a mixer IF and second IF and detector. So we had a bad detector. We had a mixer that was had broken off. The leads had broken off the board, and a resistor had fallen off as well, and all the electrolytics changed out. That's it, fixed. Thanks for watching, guys. Thanks for being a Patreon. And again, you guys are going to see more content. Tell your friends. If you want to see more exclusive stuff, this is where you're going to see it. You're not going to see it on the regular channel. You're going to see the basic fix on the regular channel, but all the extra stuff like going the extra distance and changing out all the components to show you the difference between making it work by changing just the one part and doing a full restoration and how much of a difference it made. I think if you look at, or you go back and look at how loud it would go prior to changing all the rest of the caps there was just no question that we had to do it just to restore this thing. Plus, it adds a lot more value to the collector that owns this. It's going to be worth a lot more money now that it's been fully restored. Thanks for watching.